So 14 says, if the results of the hypothesis test turned out to be statistically significant, will we be able to conclude that taking an aspirin caused the physicians to have fewer heart attacks? So they're asking if we can claim cause and effect. You want to remember, in order to claim cause and effect, we need to make sure that we have random assignment, that they were either randomly assigned to take the aspirin or randomly assigned to take the placebo, so that way we eliminate any potential confounding variables. So we can say yes, because the participants were randomly assigned to take either the aspirin or the placebo. So 15 says, the mean of the randomization distribution is 0.000092. Why is the randomization distribution centered at that value? So whenever we're dealing with a randomization distribution, it assumes that the null hypothesis is true. So it's going to be centered around whatever the value is in our null hypothesis. So if we assume the two proportions to be the same, then their difference is going to be 0. Because then the distribution was simulated assuming the physicians are equally likely to have a heart attack whether or not they take an aspirin. So the correct answer would be C. We know what is the sample statistic with the correct notation. So a parameter of interest, the proportion of those taking aspirin minus proportion of those taking the placebo. So our statistic, we just want to put hats on them because we don't know what the actual parameters are. We don't know the true population proportions for aspirin and those with placebo. But we have the next best thing, which is our sample statistics. So if we look up, it's going to tell us that it has a sample statistic of negative 0.0077. And then the randomization distribution above has 0 samples at or below the sample statistic. Then what is our p-value? So all we want to do is we want to count how many of these dots are at or below negative 0.0077, because it's a left-tailed test, because the alternative hypothesis was less than. If we see we have 0 dots below, then we just want to divide by the total number of samples that we have. We have 200 different samples, so our p-value is going to be 0. So let's see if the null hypothesis was true, if taking an aspirin wasn't any more effective than not taking anything at all. The chance that we would get a sample statistic of negative 0.0077 or smaller would occur 0% of the time, meaning what we saw isn't very likely to happen by random chance.